Cinema4d is a 3D software package from Maxon mainly used by the motion graphics industry. Here is a showreel from Maxon.
Shake it up, be cool, work it out, do you? I get down, I get show me just what you got. Shake it up, be cool, work it out, do you? Shake it up, be cool, work it out, do you?
It is a great tool to animate and visualize ideas, concepts, material behaviors, and processes in a wide variety of graphic styles ranging from diagrammatic to realistic. You can use it to fake how materials behave, but unlike other softwares like COMSOL, Abacus, it can't realistically simulate material properties. Here are a few examples in the context of the work done at the GSD, categorized into material, processes, products. I'm going to give you an overview of the basic interface of Cinema4d, share with you the options of importing geometry from Rhino and Adobe Illustrator, highlight the benefits of the non-destructive procedural workflow of Cinema4d, and go in depth about the cloner object. I'm also going to give you a quick demo on how to model and animate a simple microfluidic device and simulate a superhydrophobic droplet using soft body dynamics. The user interface of Cinema4d is very intuitive. This is going to be just a quick overview, as my aim is to show you the potential of what this software can do. An important point to note is that C4D also has a really great help documentation to show what each and every command as well as a key would do. And this help documentation can be accessed by going on either going to help and saying show help, or you can also alternatively go on any command, right click and say show help. Let's look at some of the important elements in the Cinema4d user interface. This top bar consists of the main menu, which has most important components that you'll be using in Cinema4d. It has selection tools, move, scale, rotate, as well as access locks. You have the coordinate space here, which you can change from object or to world. Then you have the rendering buttons, as well as a bunch of components which deal with basic shapes and primitives, as well as camera and lighting. This area is the object manager. The object manager contains all of your scene's element objects. You can group objects hierarchically in the object manager. Let me give you an example. Let's just create a few basic geometries, starting from a cube. If I long press, it opens up a list of different geometries for me to choose from. As you can see, this area is the attribute manager. In this, you can change the different attributes associated with your selected geometry. For example, for the cube, you have the X, Y, and Z size. For the torus, you will have the internal and external radius, as well as the orientation. As earlier mentioned, Cinema4d follows a hierarchical tree system, where right now, if you see, all of the objects are within the same hierarchy, but if I drag the cubes and make it a child of the torus, now any changes I make to the torus geometry would be reflected in the children, which are the cubes, be it any kind of transformations like rotation, scale, all will be translated accordingly. But any change that we make to the child geometry, which are the cubes, will not affect the parent geometry. This is a good way to organize different elements, components, assemblies within Cinema4d. This bottom area is the material manager, where you can create and assign materials to your objects. You can create a new material by just going create new, or you can also use a shortcut of just double clicking here, which will create a very basic material. As soon as you select the material, you can change a lot of attributes like different the color, the reflectance, illumination, etc. You can, for the time being, I'm just going to change the color of the material so that we can differentiate our objects. And the way to assign material is you can directly drag and drop it on your geometry. Alternatively, you can even drag and drop it in your object manager. And as you can see right now, when I drag the material on the torus, even the cube also got the same material. This is because of what I mentioned before, the parent-child relationship. So because for one of the cubes we already assigned one material, that has not changed. So if we end up removing this cube from the parent-child relationship, it goes back to its regular form. So materials are affected by object hierarchy. You can navigate through your on your viewport by a lot of different ways. Using the mouse scroll button, you can zoom in and out. You can also do the same by going over here and holding down your left mouse button. You can go up and down to move in and out. You can pan using the same method, and also once a particular object is selected, you can also orbit around the object using the orbit tool. You can also switch between different viewports. Right now we are zoomed on into the perspective viewport, but you can press the mouse center key to go back to your 4 views. As you can see, the perspective view is displayed with surfaces, which for Cinema4d it's called shading. But you can also change the different graphic styles of how you see each and every viewport. Right now you can see in the left, right, and the front, right, and top views, it displayed in a wireframe mode. And you can switch and zoom, maximize any viewport by going to the viewport and just clicking the central mouse button. This area of the interface is called the animation palette. This is the area where you would control, edit, and play your animations. Right now you can see this area which shows 90 frames. It determines what is the last frame of your animation. So your animation timeline right now is 90 frames. You can easily edit it by just typing in it. For example, if I say 120 frames, that's how long my animation would be. It's also always good to first check what the frame rate in your animation is. You can do that by going to mode and seeing project. You can see the FPS is 30. So as compared to your timeline, if it's showing 120 frames, it means that this timeline corresponds to 4 seconds of time. Let me give you a quick example. Let's make simple primitive geometry. Let's say a sphere. When you look at the object attributes of the sphere, in coordinates you're going to see PSR, which corresponds to position, scale, and rotation. Right now our geometry is on the origin, that's why it's 0, 0, 0. If you see the y-axis pointing top, if you press 100, it's going to put the position 100 in the y-axis. And as you can see, for all of these properties, there's like a small dot on the left side of these properties. That basically means that these are the properties that you can animate. The same can be seen even in the object properties, where you have the radius. So all of these can be controlled and animated. Let me show you a quick example of how to do that. So let's say This window shows us the current frame where we are at. Let's go to frame number 0. Let's try and animate the Y position of the sphere. So now that we are on frame 0, let's click the button next to position Y. Once you click the button, you will notice that there's a keyframe which is created here. Now we go to frame number 60. And as soon as we go to frame number 60, you will notice that the solid red sphere has now become a red outline. That means it's waiting for the value. So for position Y, let us enter, 90 centimeters, maybe more, maybe 300. And as soon as we enter the new value, you will see that the red outline turns to a yellow outline. That means the keyframe still needs to be assigned. So you press the yellow outline and now you see it's solid red. And you will also see a keyframe formed here at frame number 60. So now if you go back to your first frame and you play the animation, you will notice how easy it was to just simply animate basic translation. We can animate multiple properties at the same time. As you can see, we already have the y-axis translation animation in the key timeline. So now what we can also do is, right now that we are in frame number 0, let's also change the scale of the sphere as it translates in the y-axis. So I'm going to put a keyframe for all scales because I want it to scale uniformly. Then I will go to frame number 60, and now for scale, let's say I want to make it 0.2 in all 3 directions and assign keyframes for the same. Now when you play it back, you will see the sphere scale down as it translates. Let me show you a quick way to have a simple setup for rendering using 2 lights and a camera. Lighting is super important to get a really nice realistic render. So let's start. I'm going to start by going on the side view, going and taking the spline pen. The spline pen is very similar to the pen tool that you find in Adobe Illustrator. I'm going to do a B-spline. You can turn snapping on and off here. If you long press, you can snap on to the grid points. I'm just going to create a simple curve. Press escape. You can see in 3D we have this simple curve. This area you can actually toggle between selecting the model, the texture, the points, the lines or faces. So as you can see right now I have the curve selected with the model. It selects the whole curve. If I click the points, I can actually change individual points if I want to. For now we just need the simple curve. I'm going to extrude the curve to form a surface. So for extruding, I just place the curve in extrude. If I go to extrude, I have the direction automatically selected. Let me increase the offset to create a good sort of back plate for our renders. I'm going to bring the plate so that its center is very close to the center of the origin. So we have the back plate. Let's add a camera. By default, whenever you add a camera, it takes the user's view position and places the camera. You can go in your top view to see how it's added this camera. I'm going to zero it out, so go to camera, coordinates, and you see all the values of x, y, z position as well as rotation. If I right click on these, it's going to get it to a 0 value, and hence you have the camera pointing towards the z direction. And this point you can adjust the focus, but we'll get back to that once we insert our object in. So when you go to your perspective view, you can see here right next to the camera you have this sort of frame. When you click it, you're going to assume the position of the camera. Be careful in this point, because if you're assuming the position of the camera, if you pan, dolly, zoom or orbit, it's going to change the position of the camera. So it's always good that when you are in the camera, you always change the camera positions based on the coordinates here. So for example, if I increase the y direction, it's going to lift my camera up too much, maybe more like 250. Now let's add some lights. Let's maximize to the top view. So in order to add lights, you can see in this button, if you long click, you'll see the different kind of types of light available to you. You can test out a lot of these different lights. I usually go with PBR, which is physics based rendering, and this kind of light is going to give you sort of the most realistic light as compared to the real world. So I'm going to pull the light back. The light which you see here with the z-axis, it always it emits light in the z-axis. So I'm going to have two lights, one on the left and one on the right, very similar to what you would do in like a physical photo studio. And let's push this one on the left. I can turn off snapping, and I want to rotate it 45 degrees so that it sort of points towards the center. Let me do -45. Wrong direction. I want to rotate it along the z direction. So oops, that is fine, maybe -45. So we have one light. Let's name, oh, why do we have two lights? I'm going to delete this one. Let's name this one light as a main light. When we go to generals, you can adjust a lot of settings that are associated with the light. Like right now it's giving us a white light. You can change this if you want any colored lights. We can also play with the intensity of light, which we'll see when we make a second light. You can select what kind of light you want, different types like area, spot, etc. You can enable, disable shadows if you want soft shadows or hard shadows. So there's a lot of different options that you can explore. Let me make a copy, Ctrl C, Ctrl V of this light, and right now I want to shift it on the right. Right now you can see the axis is in object mode. If I do it to world mode. It gives me axis parallel to my world, and I'm just going to pull that light here. I'm going to go to coordinates. Instead of 45, I'm just going to, instead of minus 45, I'm just going to do 45, so it just mirrors it. So now I have two lights pointing towards the center area here. I'm going to go back to my side view. I'm going to select both the lights and lift them a little bit up so they're in the same sort of line as a camera. You can see the illumination caused by the lights on the back plate. Only one light got lifted. Let's do it for the other one. I'm going to name the second light as my fill light. I'm going to go to the fill light in general and reduce its intensity from 100 to 60. So now we have a sort of basic scene setup. You can always switch from camera view to your normal view by clicking this frame. Once you click this frame, it gives you sort of more flexibility and also helps you not to move the camera from its initial sort of position. One way to ensure that the camera doesn't move is to apply a protection tag to it. Protection tag is a tag which in Cinema4d helps you lock the position, scale and rotation. The way to add a protection tag right now, if you right click, because I'm using a different version of Cinema4d as compared to the ones you'll be using, if you go, there'll be a Cinema4d tags and you can see into the list there'll be a protection tag. For me it's here in rigging where you have protection tag. As soon as you add a protection tag, you can see we have the PSR, the position, scale and rotation locked. So now this camera is not going to move unless I unlock it. So now I don't have to worry about it changing its position if I am clicking my mouse or doing any sort of translation or zoom, etc. So this is a good way to help your camera stay in place. Now let's try and bring a sort of object or whatever you have designed. I'm just going to take a object which I have saved here with me by saying merge object, maybe. Okay, let me just add it from my library. So yeah, I have this model of a skull which I'm going to use for demonstration. I'm going to remove its material. I'm going to reduce the scale of the object so it's sort of proportional to my frame. I'm going to go to the top view. Maybe I'll reduce the scale even more. Align it to the center. And this looks proportional. Now the object I imported already has materials with it, so what I can do is I can just delete all the materials and just quickly show you a quick way to add interesting materials. So double clicking made a new material. I'm going to add it to the skull and then double click it. In color, as I mentioned earlier, there's options for different colors. Let me Another very interesting aspect about Cinema4d that you can find a lot of inbuilt materials, and one way to sort of do it, look at the inbuilt materials, is here you can see you can go to the content browser. You can just search for the material, for example wood, and you can see there's a lot of pre-built materials which will give you a quick way to just add material. So I drag the material from here to my material attributes, and I can just drag and drop it to my geometry here. And now if we just do a quick render, this is going to be like the most basic render view. You can see it takes a little bit of time based on your computer specs. But it's pretty quick, the Cinema4d rendering engine. Now you can see the render is not that great. We're not getting great shadows here because the light is probably too direct. Can do a few changes of maybe lifting up the lights, taking my main light on the left because it has a lot of highlight. I'm going to reduce its intensity to maybe 85. Let's see, re-render. So you can see like how a simple setup and lighting can just make a huge difference. Maybe this wood texture is too sort of complicated. One thing you can do is just take a different texture, maybe metal. See, brushed metal. I'm just going to go to my geometry, delete the two materials and add the brush metal and say render. Textures like metals, because they have reflections, it takes relatively larger, it takes more time for it to render. So we can change a lot of different aspects and properties from the render settings to make it look more realistic and the lighting sort of more real world. So for render settings, you can go here. I'm not going to go too much into detail. You can always right click these properties and see the help where they have a detailed explanation for each and every aspect of this. But one sort of quick sort of tip is that from Cinema4d you can generate two different kinds of so there's like two spectrums. One on one end you have something which could be super diagrammatic, looking very much like a cartoon, or you could have a very sort of photorealistic rendering, something that how the object would look like in the real world. So within the renderer, if you choose standard, you could do more of like a diagrammatic effect. For that, you can go to standard. In effects, you can say cell renderer and just quickly show you how that would look. So once we have cell renderer on and we render, it's going to give you just the outlines of the object, which for some cases might be interesting to be used for diagrams or taken to Photoshop to overlay things, almost like a make 2D projection. You can also go to cell renderer and select color and edges, and then when you render, you'll actually see the mesh on your 3D object, which it gives it sort of like a hybrid look of a sketch. Another quick way is, another different style of it is, first I'm going to turn off cell renderer. While I'm still in the standard renderer mode, I'm going to go to effect and select sketch and toon. I'm just going to leave the properties to its default so that you can see the impact it has. Just give me a silhouette of the object, but you can play around with a lot of these different styles. One sort of setting to make it look more photorealistic is, because we've already used the physics based rendering, we can go to the renderer and select physical. One of the options that you would want to go and change is in physical, you go to options, in physical, and say depth of field. And you can also add effects, ambient occlusion, and effects, global illumination. These, I'm not going to explain what they are. You can probably like look into, just Google what they mean, but they deal with the way light reflects. And just like a quick tip about both of these is that if you want to get one level of sort of how realistic your object wants to look, you turn on ambient occlusion, and if you want it to look really much like what you see in real world, you turn on global illumination. When you use both of these, it becomes very computationally intensive. So remember that if these are on, it will take more time for you to render your scene or frame. I'm going to just lower the effects of these, and I'm going to render. Because I have physical selected, I'm just going to render here. It will take relatively more time as compared to the first render which we did, but it's going to look more realistic because it actually takes into account the different lights that we have in our scene and how many times the light rays bounce and reflect. And in this physics-based rendering, as mentioned before, we can also play with the focus, the focal length of the camera. We can actually change it so that we get a shallow depth of field, so that your background is more blurred and the objects which are in front of you are more sharp. So all of those things are settings that you can play with in order to make your scene more realistic. One way of changing the focus of the camera is selecting the camera. You can basically select this point and it's going to determine the focus. So if we have the focus almost at the nose or the eyes, we go to physical, and in the camera settings, f-stop, which basically in photography terms is the aperture. So the lower the aperture, the more the depth of field that you're going to get. And there's a way to actually visualize that by turning depth of field on. I'm going to push the background a little bit. Let's see if I can render that, if maybe exaggerate the depth of field more. And right now I've been rendering in the current viewport. If you actually want to save the render, you can do so by clicking render to picture viewer. So now I'm going to do this, where it's going to save it. You can specify particular folders and settings where you want to save the renderers to in the rendering setting. You can notice that there's a slight blurriness in the background, which is caused by the depth of field. You can exaggerate it more if you have a background which has certain kind of patterns, so it will be more prominent, the sort of change in depth when you're using a depth of field. Here are some full resolution renders which I did with the sketch and tone by changing materials, wood, metal, and also some adding an effect called atom array, which shows you the wireframe of the object. A lot of different file types are compatible to be imported into Cinema4d. Mainly I model most of my 3D objects in Rhino and then import it in Cinema4d. You can also use a simple software like Illustrator to draw simple splines or lines and import them into Cinema4d and animate them. Some of the sort of common options to smooth this transition of importing geometry to Cinema4d from Rhino and Adobe Illustrator, you can look at the options here. Another really amazing aspect of Cinema4d, it's the hierarchy of the objects and its ability of non-destructive procedural modeling, where every object is still intact, and when it follows a certain processes, you can still change the base object and all the changes will follow through. Let me give you an example. Here we have two splines. One is a simple line and another is the Cinema4d flower object, which can be found here in the flower. And the flower object, in the properties we have the ability to actually change the number of petals that it has, and both of these lines are added as an input into the sweep knob, which would sweep the flower along the line, and the result can be seen here. In the sweep knobs you have different options starting from start growth to end growth, all of the properties which you can animate. You can even have like the end rotation, which can cause a twist in the object. And this sweep knob has a deformer applied to it, which is bend, which you can see when you turn it on here. I'm going to have the end growth as 100, and now that we have the whole knob as bent, and rotation I'm going to put it as 180. And now if we go to the flower and if we change the petals, you can still see that the same is being reflected even after the bend. And after the sweep knob is bent, we are again adding a twist to it, so you can see. And now again, because the whole process is non-destructive, I can still go back and change the dimensions of the flower as well as change the number of petals, and you can see how the whole result after bending and twisting is still translated within the geometry. Now I want to show you a really cool and powerful object in Cinema4d called the cloner object. It is the object for the duplication of other objects, arranging clones onto vertices of other objects as well as splines. The cloner object sets your object up so it can be affected by various effectors. Let's do a demo. So let's start by taking a basic sphere. I'm going to make this icosahedron, increase the facets to 20 and decrease the size to 50. Now let's go and get the cloner object. You can find it in MoGraph. One more quick tip here is sometimes when you know the object that you want but you don't know the location of it, you can use the shortkey of Shift C and just type the command or the object you're looking for example cloner, and you can directly add it. So in order to clone an object, you need to make the object a child of the cloner object. So as you see, by default it's on grid array. Just for simplicity, let's just focus on the most basic version of it, where it's a linear array. In the linear array, you can see right now the clone is set to iterate. You have the option of having multiple different objects as clones too, which I will show you later. Right now I will just show you the basic of a cloner object. So right now we can see that the count is 3, so the number of clones are 3. We can increase that. Instead of it going in the y direction, which you can see by the position here, let us have it go in the z direction, or maybe x, whichever. You can try out different things. You can increase the position so that there's a little gap left between the objects, and maybe increase the count more. So as I mentioned before, you can have multiple objects in the cloner. So let's make maybe a cube, turn down its size a little bit similar to the sphere, and what I'm going to do is I'm actually going to add a material to the sphere. I'm going to add a material to the cube, and let me make another basic primitive geometry of a torus. Let's turn down the size and the pipe radius and give it another material. So now we have a sphere which is already a child of the cloner. Let's do the same for the torus and cube. And now you see we have all the 3 objects have been cloned based on the parameters set in the cloner, and they all will follow the different options that are there in the cloner. So right now we are just changing the position. We also have the ability to maybe change the scale of objects also. See it in 3D. If you want to scale it uniformly, we can just say 150, 150, 150. So a lot of these objects have blended, so if we increase the size, the position, let's just turn this a bit down, back to 100. And turn the position a little closer. If you press the O key, it will directly zoom in to your selection, which is a quick way if you suddenly get lost in navigation. Another really cool aspect of the cloner is the step rotations. So as I mentioned before, you can change the rotations of your individual clones also through the options of the cloner, but you can also change the rotation of each and every object with respect to the previous object through the option of step rotations. So for example, if you see, you can Also twist it in other dimensions. Sometimes these options can be very useful when you're creating sort of organic, like a chain of organic objects or particles, etc. And as I mentioned before, because all of these options have dots, it's very simple for us to animate these clones. So just as a quick example, let's zero these values. Let's say zoom out. We are on frame 0. Let's turn on step rotations, all 3 of them. Let's go to frame 30 and change the value of these things and set the keyframe. Oops, sorry. And you go to the first frame, and then when you play, quick animation. Okay, let's go back to our first frame and let's remove this animation. You can do this by right clicking, going to animation and clicking the delete track, which should be seen here. If we go back to the cloner, we can also look at the different modes. So if you say radial, you see this tiny radius ball formed. Let's just increase the size of this and increase the size number of clones. Will form like radial clones. You can also look at grid, which will create a grid array of clones. So 6. It's also possible to go in the Z direction, but for the sake of simplicity I'm just going to work in 2 dimensions. And let me show you effectors. So whenever you use cloners, you have these other objects called effectors, with which you can perform a lot of interesting behaviors from the clones in a cloner. So let me go to the linear mode. Once you have the cloner selected, you can actually go to MoGraph, which is motion graphics, effector, and you have a bunch of different effectors here. You can just test and try out these. You can put them in the scene, right click and just look at what they do by going to help, but I'm just going to show you a basic plane effector. What a plane effector does is that it will change the parameters of a clone based on what you select, be it position, scale or rotation. So right now the position is selected, but the plane effector by itself won't work, because right now you see all of the clones are moved, translated in the Y direction. But in order to use its full functionality, you need to go to fall off. In fall off, you add a linear field. So as you can see, you added a linear field, and what the linear field does is that it creates a transition between the two extremes. So for example, if we say in the parameter that we want the position to increase by 200. All of your clones which lie before this end would be all 0. All the clones lying after this end would be 200, and all of your other clones in between would follow a range between 0 to 200. So let me go in the plan view. Select the linear field and try to fine tune a few of these properties. So if you see in side view, you can see how if I have the linear field selected and I move it along the x direction, or let's just see it in 3D view. You can create a really nice sort of animating transition here. And the same will apply if you go to cloner and instead of in objects, instead of linear, if you do a grid, so you can create really interesting sort of animations and behaviors using this. Like for example, you can use these effectors to showcase how certain materials behave under the influence of certain stimuli, like an object or a magnet, etc. So let me show you another effector. For the sake of simplicity, I'm going to remove the complicated geometries and keep the cube. I'm going to delete the plane effector, and I'm going to go to the cloner and increase the number of my cubes and decrease the size, the distance between them. So another really cool effector that you can use with the cloner is the formula effector, which you can find in MoGraph. Effectors formula, and right now if you go to formula, if you go into parameter, you can see the position and scale are affected. You can choose to affect one or all of them. So let's just look at the position. Maybe instead of x, let's see, we want to change the position by 100. If you see in your 3D view, right now you have, let's increase maybe this number of clones. What the formula effector does, that if you go into the effector, you actually have a formula here. You can look at what the variables mean right under it, but what this formula will do is that it will basically control the y position of all sets of clones. And because in the formula you see you have the parameter of t, which is time, which is based on your timeline, so every frame number the value of t will change, and hence you will see that throughout your clones you'll have a wave go through. So if I play, you can even go and see, look at it from a side view. This is a better view. And you can change things in the formula and see how it's going to affect your clones immediately, like in real time. You can change the frequency or amplitude and different parameters of your clones. So it's pretty amazing what you can do with the formula effector. Let me show you another quick effector using these same clones. Go to MoGraph effector and just say random, and you can see how they're sort of randomly dispersed. Instead of position, you can also say just scale. In scale, let's say uniform, maybe 0.5. So you have sort of a bunch of randomness in the scale, and we can also say we want not the x and not the z, but only the y position affected. And if you increase this, you just get almost like a point cloud of clones. You can copy your same cube a bunch of times here if you want to give it different materials, and add it back to your cloner. Create some interesting clouds, and you can turn on and off any effectors. You can use multiple effectors. For example, while this cloner is on, also let me add the formula effector. We're going to change in scale, and because in the formula we have time, you can get interesting sort of behaviors like these. If you go to cloner, you can even see the different effectors that are affecting this cloner. You can turn these effects on and off, or you can use all of them together. Let me show you the sort of last type of cloner. Now let this, so this tick mark, basically you can turn on and off objects and effects. So let's just turn it off instead of removing it. Let's create a, okay, let's just keep this as our clone field, and let me create a sphere. Let's give the sphere a color. And another interesting thing you can do with the cloner is use this effector called target effector. This is a really cool effector. What it does is it tells all your clones to target a particular object, and in the target effector, I'm going to select the target object as the sphere. And you can also make it target it with all three axes, or if you say don't you if you unselect use pitch, it's going to target it only with the two axes. So now if I take my sphere and I move it, you can see how the clones are responding to it. If I go back to target and say use pitch and select my sphere, so this sort of animation, you can actually imagine that if you want to visualize certain sort of atoms or certain tendrils or surfaces which are reacting to water or any sort of stimuli, it's very simple for you to use these effectors and cloners to fake that behavior. One more interesting thing I can show you is, instead of the material here, I've made a particular material which replicates iridescent material, where based on the angle that you see the material, it changes color, which I can show you. So now that I've applied a iridescent material here, I'm going to also just put a light in. And if I hit render, so you can see that the different colors you are seeing is because of the different angles which are facing the light of different surfaces, and you can create a lot of interesting sort of effects just by changing that. So for example, if I have the sphere, I go to coordinates and x-axis, I add a keyframe, I go to frame 60, I pull the sphere, here, and I add another keyframe. You can see how it was so quick to animate. Here is the rendered version of the quick animation, and another version of the cloner with a formula effector. Let me show you a quick way to model and animate a simple macrofluidic device. I'm going to take the same example file which Jonathan has shared with you and the same channel geometry. I'm going to export the geometry from Rhino as a IGS file, and I'm going to import it to Cinema4d. I'm going to use the same options as I had specified earlier for a smooth transition from Rhino to Cinema4d. Now to import the curve geometry in Cinema4d, we are going to go to File and do a file merge. I'm going to select the IGS file. I'm going to keep the settings the way they are. And here we have the curves from Rhino. If you press the O key, you can directly zoom into the selected object. As you can see, we have all the curves as separate. So one sort of way, little bit of housekeeping that you need to do with the geometry is, let's see, so we have all of these curves belong to the channel. So I'm going to select all of them in the object manager, right click and say connect objects and delete. So right now we have the whole channel geometry as one single sort of curve object. I'm just going to rename it as channel, and I'm going to rename the other curve as plate. So now I know what it is, and I'm going to select both of them and remove them out of this container, a null object. And right now you can see I have selected the plate object, but the axis is all the way to the origin. I want the axis to come to the almost the center of the object. One way to go about it is going to mesh, axis, and say axis center. Let's select the points, use all objects and auto update. You can see we have the axis come towards the object, and we can do the same for the channel object too. And okay, now that we have the axis almost on the object, what we can do is go to the plate, go to the coordinates, and we are going to put both the objects in on the origin. So I'm going to just zero the position X and Y out. I'm doing them with a shortcut of just using my right mouse button. In top view, you can see that the geometry is not perfectly aligned, but that's okay. I'm just going to press O. I'm going to have the plate sort of come in the visual center. I think that should be okay. Now what we're going to do is we're going to extrude 3 copies of the plates and create a sort of a sandwich. So the way to do that is we go to the extrude button and we make the plate a child of the extrude. If you go to extrude right now, in object the offset is 100 centimeter. We want to reduce that to probably 0.2. I'm just going to name this extrusion as extrude plate top. I'm going to copy and paste 2 times. say bottom and mid. I'm going to go to the side view, press O to zoom in. You can change the display mode to shading so that we know where our object is. Let's select plate top and move it a little bit on top. It's always good to leave gaps because while rendering we don't want the overlap in surfaces to change how we are going to see the object in different light. So the bottom plate, move it a little bit down. And let's just apply a quick texture material to the plates. I'm just going to go to my content browser where there's a sort of repository of materials that come with Cinema4d. Type glass and select glass simple, and I'm going to apply it to plate bottom, control and copy it to my plate top. And for now I'm just going to turn off the top and bottom so we can focus on the mid plate. Now what we need to do is also extrude the channel so we can subtract it from the mid plate, and the way to do that is we can actually use the same extrusion button here which we've used. So what I'm going to do is just copy and paste the extrude which we did for the plate. I'm just going to name this channel, and I'm going to remove the spline of the plate and replace it with the spline of the channel. I'm going to, so as you can see now we have sort of a 3D extrusion of the spline, and now we want to subtract this channel extrusion geometry from the mid plate. So the way to do that is I'm going to be working with these two extruded objects. There's a command called bool, which stands for boolean, and the way to go about it is you have in boolean you have a subtract b. So the first object would be a, so I'm going to select the middle plate, make it a child of bool. So it's going to be object number a, and I'm going to take the channel and make it object number b. You can see right now that you can still see a bit of weird surfaces in the top and bottom, just because I think the height of the channel etc is not placed well. What I can do for that is I'm going to go to the extrude channel object, and instead of 0.2 I'm going to make it 0.4, just so that there's a clear subtraction. I'm going to size it a little bit up so that we have a clear channel subtraction here. Okay, that's good. Now let me just also make a quick material to showcase our fluid. I'm going to make it red so that it can be seen brightly, and I'm going to add a little bit of luminance glow to it, which is also red in color. So now what we have to do is that right now our current channel that you see here, it's just a void. It's been used for performing the Boolean operation. So in order to actually show the liquid, we need another extruded channel, which I'm going to create a duplicate. Just Ctrl C, Ctrl V, and I'm going to color this channel as red. So now you can see, now we have a solid red channel here. On the middle plate. Okay, so I'm going to also add the glass material to my middle plate, which is the boolean. So now you can see how our microfluid device is looking. Now, in order to do a quick animation, what we can do is again use the bool command, and I'll show you how you can fake sort of the fluid flowing from one end to the other. Let's just create a cube, reduce the size a bit, even more, maybe 5, and try to make it cover your whole channel till a certain point here, leaving just a little bit of the channel intact. And now we're going to add another boolean object and subtract the cube from the channel. So what that does is, I'm going to increase the size of the cube here, and now you see, because I'm subtracting the cube from the channel, if I move the cube, it's going to give me a perception that there's a liquid flowing from the left end to the right. So I'm going to get the cube back to the start position, and I'm going to animate the position of the cube. So I'm going to go to coordinates. Right now we have a total project timeline length of 90 frames. I'm going to so there's one command here called freeze transformation. So regardless of where your object is in space, if you say freeze transformation, it's going to give you a sort of 0 options for all. So it's just a good way of zeroing it, your object location or scale or rotation, so that you know how much distance you're covering. I'm going to be animating the X axis, so I'm going to put a keyframe for X. I'm going to go to 60 frames. I'm going to move my cube all the way till the end, and I'm going to click and set the keyframe. So now if I reverse and play, you can see a quick sort of way of how simple it was to just animate a microfluidic device. I'm going to add, just for the sake of like a good scene, I'm going to add a floor, move it a little bit down so it doesn't overlap with the geometry. Oh, I'm going to turn on the top and bottom plates, which I forgot. And I'm going to reduce the glow of our fluid a little bit. Let's try and see how it looks by rendering it here, one frame. just a still image. Okay, it's looking good. One more interesting thing we can do is when we are rendering it out, we can also give a sense of scale to this object by, for example, I have saved with me a material with a grid on it, and I'll share these files with you so you can also directly use the same. I'm going to apply the grid material to my flow. And now let me render. And here is the rendered animation which we just created. Now that we have a whole scene and object hierarchy set up, it's also very simple for us to change the channels that we have here. And instead of using an extrude, we are going to just try and use another command, which is sweep. So let's do that. I'm going to turn off the old geometry just so that it's easier for us to understand. Let's go to the top view. Use the spline pen, and I have snap on, so I can just snap easily to the grid. The spline pen. I'm going to create a simple curve. And having the spline selected, instead of linear, just going to turn it to Bezier, so we have a smooth curve instead of a polyline. Now this curve, let's go to the 3D view. Let's also go and create a small circle of the point 2, a circle that we can sweep across to create a 3D channel, and find sweep here. So making the circle, which is the cross section curve, a child of sweep, and the spline under it, and you can see I'm going to also see where my sweep is positioned. I'm going to position it a little bit in the center so that it completely overlaps this central channel. I'm going to turn off the bottom and top plate just so that it's simpler for us. So now this Boolean operation is corresponding to the earlier geometry. What I'm going to do in the Boolean operation, we set it up so that we have the middle plate, which is the base geometry, and we are subtracting the channels from it. So now instead of the old channels, I'm just going to remove those channels and put the sweep in place of the channels. I'm going to also turn the visibility off for the old geometry, and now you can see that we have a middle plate with the sweep geometry subtracted from it. Let's go back here, and now we follow the same process as before, where we want to have the same 3D geometry of the channels in order to simulate the flow of liquid. So I'm going to just create a copy of the same sweep. Now I have the 3D geometry. I'm going to assign the material to it. And one really nice thing about the sweep object is it has a parameter here called end growth, which you can easily animate, which gives you a sort of flow. It fakes the animation of a liquid flowing. So what I'm going to do is go on my frame 0, maybe start with 12%, and I'm going to create a keyframe. Just type 12 so I can see the keyframe here. Then I go to frame number 60 and I increase this to 98 or 100, and I register another keyframe. Now when I go back and play, you can see the sweep animating. And let me show you a rendered version of this same. Here is a quick overview to create dynamics in Cinema4d. We are going to have a quick look at rigid dynamics in the start, as well as soft dynamics to deal with soft bodies. So let's go ahead. I'm just going to create a simple scene. I'm going to add a floor, push it down. I'm going to create a cube and make like a small slide. 20, 400. And I'm going to create 2 spheres. If you go into display, you can actually see the edges that they make the sphere. Usually for dynamics, I always tend to change the type of the sphere from standard to icosahedron, because it has a sort of more consistent distribution of faces. I'm going to make it smaller, let's say 15, maybe 25. Go to the top view. I'm going to place the sphere sort of in the left side of the plate here, and I'm going to name this sphere Z. I'm also going to make another copy of the sphere. Holding down the control key, I can just drag it to make a copy. And I'm going to name this one sphere blue, or blue, just to distinguish between the two. Right now you can see only one sphere because it's one on top of the other. I'm going to take the blue sphere and move it slightly on the right. And I'm going to select both of my spheres and lift them a little bit up in the Y direction. I'm also going to quickly make a few materials so it's easier to see our different objects. Let's say flow. say red. We'll make this one blue. And let's give the material of the plate as I've already so I have a few materials which I've created and stored. You can also do the same by basically selecting the material here in your material manager and going to create and saying save material preset, which is here. I have a few presets already saved. One of them is the reticent material, which I have used earlier, and I'm going to select that. I'm going to apply it to the slide. To apply the blue one to the blue sphere and the red one to the red sphere and the floor to the floor. And as we know that the iridescent material is dependent on the position of the light, I'm going to introduce a simple light. Select the light, give shadows as soft shadows. And lift it up, maybe simpler in this view. And a little bit on one side. Now you can see the sort of quick view that we have. Maybe for this exercise we do not need the floor. Or let's just keep it. I'm going to go to the light and decrease its intensity to 50 or something. For now I can even just turn off the light so that we can see our objects more clearly. So in order to set up dynamics in Cinema4d, we are going to sort of use these two spheres as examples. I'm going to put a basic dynamic tag for the red sphere and also the blue sphere, but I'm going to keep making changes to certain properties of the blue sphere to see how those changes will affect the sphere as compared to the red one. So the basic dynamics can be accessed by right clicking here on the object, going to simulation, and these are the different tags which are available. I'm going to assign a collider body to the plate, knowing that it's not going to be moving, and I'm going to follow the similar process for the red and blue sphere, but instead of the collider body I'm going to add a tag of a rigid body. And you will notice here that the tags which I applied can be viewed here, and when you click on it you can access the properties of the tag here. So right now I'm not changing any settings, I've just applied the tags here. If I go on my timeline and just press play, we have sort of a default gravity acting in negative y, which it considers. Let's go back to frame 0. let's do another quick change. Let's lift up a slide, go in top view, push it a little bit in the Z direction, and let's incline it so that we can see the sphere as it drop and slide. And when I hit play, let's also just create a small box so that we can collect the spheres after they drop. I'm going to create a cube, move it towards the end of the slide, change the height to 50. And I want to actually remove the top surface, so for that I can actually use this command called edit, so edit make editable, and then use the face selector to select the topmost face and just delete it. Go back to object mode, and even for the cube I also have to assign it a collider tag. And now when I play the animation, okay, so now let's go a little bit deeper into the different properties of the tag. So I'm going to leave the red sphere properties the way they are and just keep changing certain properties of the blue sphere so that we can look at both of them in comparison. So now, for example, for the blue sphere, if I increase the bounce from 5% to 60%, I'm going to display let's play and see. You can see that the blue sphere tends to bounce quite a bit as compared to the red one. Now, right now we have the bounce as 5 and friction as 90. Let's go to the blue sphere. Roll back to 5% as the bounce. And let me make the friction as 0. Now we can see how the blue sphere, instead of rolling, will actually slide on the surface. Now there's a lot of different properties that you can play with, and I would recommend sort of just going through all the properties, and the best way to sort of know in detail about them would be to just right click and look at the Cinema4d help. there's a very nice detail in the explanation given for each and every one of the properties and all the associated parameters for those properties. So right now, whatever dynamics we are looking at, because we've assigned the body a rigid body tag, we are looking at rigid dynamics. But now what I'm going to do is I'm going to go to the blue sphere tag and go to the soft body tag, which you see here as off, but I'm going to basically turn it on, and now you'll see the difference in between. I'm going to also go to collision and roll back to the same properties. So we have the properties of the red and blue sphere in terms of these as parameters are exactly the same. Now the only difference is red is a rigid body and blue is a soft body. And probably turn on the display of the line so it's better, easier to understand. And even within soft bodies, there are a lot of these parameters which you can manipulate to try and sort of model certain liquids with certain viscosities and stuff. It's not like a direct value that you enter, but you have to keep changing a lot of these values in order to get the effect that you're looking for. Let's also add a camera. So right now, as I had mentioned earlier, the camera is added to the current view that I'm looking at. What we can do is also right click on the camera, and in the camera, in the animation tags, we can select target and have the camera target a particular body. In this case, we are going to target the blue sphere. So right now we are not exactly assuming the view of the camera, and you can do that by clicking on this frame here. And now if I go to my first frame and hit play, we have a very quick animation of focusing on the blue soft body. So right now it's just following the soft body. You can go another level deeper by going to the camera, and for as a focus object you can select the same blue body. Going to the physical tabs, as I mentioned earlier, if we reduce the aperture, you can actually see a nice depth of field for that particular body with respect to its background when you render it. Turn on the light. Actually, for this scene I'm just going to not have any shadows for the lights, to just keep it simple. And if I render, you can see a very simple scene. With the animation of the soft body, I can again go to the blue sphere, soft body tag, and in collision, if I don't want it to roll, I can just reduce the friction to 0 to make it slide. And this is one way how you can sort of simulate if a particular liquid you want to highlight the behavior of some superhydrophobic surfaces. So you can just see how the blue sphere reacts now. It's sliding as compared to the red sphere, and it is a soft body. Let me do a more, I am going to render a sort of full resolution of this and show you here.